Technology,
science,
space,
environment,
people.
places.
It's all totally awesome.
Welcome once again to Totally Awesome. On today's show, going to a bar. Not for a drink, but for a breath of fresh air.
Keep your ears open because we'll be hearing all about artificial skin.
We take a trip to an amazing mountain that keeps burning all through the night.
And this man can play you a popular tune. The instrument? Wine glasses.
This is St Luke's Hospital in the north of England. Here, Professor Alan Roberts and his team are combining artistic and scientific skills to make carefully matched body parts to replace those that are diseased, damaged or have been amputated. It's here that science is at its best with the invention of artificial skin, which is made from biodegradable implants and leaves the body when it's no longer required. They've also developed tissue glue that allows wounds to be closed without sutures. Combined with modern keyhole surgery, where surgeons operate through small holes in the body, the glue means quicker wound healing time and shorter stays in hospital. In the future, scientists predict that it will be as simple as looking at the size of the wound and running the fluid across it. The wound would then close within 10 seconds. This technology would reduce infection, scarring, and would mean many procedures wouldn't need anaesthetic, especially on skin of small wounds. But it's making lifelike body parts for export to surgeons around the world that the department has gained its biggest reputation. An ear, nose or finger starts off as simple paste. Dyes are carefully added to make the skin tones match. Then the paste is moulded into the body part needed. The flexible material produces more natural looking results. They have even had success reproducing fingers that have some movement. There seems to be no limit to the body parts these gifted scientists can come up with. Gripping, isn't it? They may look like ordinary bags, but these refrigerated cases contain human tissue. It has been donated by relatives after the death of a loved one. This particular tissue cannot be used in operations to replace somebody's damaged kidney or heart, for instance, but it can be of great value to medical researchers. Bob Anderson, who heads the newly established Human Tissue Bank, says the users of the tissue are bioscientists, being the biologists, cell biologists, toxicologists, people who look at the risks associated with taking drugs, people who are trying to find new drugs, and medical doctors researching basic medical and biological problems. One problem is finding out how new drugs will affect us. By studying a drug's action on human liver enzymes, its effect on humans can be accurately predicted. But the donation of this human tissue is full of ethical dilemmas. That means that people feel that using human tissue is not the right thing to do. Previously, testing was done on animals to find out the cause and effect of drugs. It is thought that using the skin donations will reduce the need for this, while giving scientists the information needed before trying the drugs on live humans. Dr. Anderson hopes to encourage more people to think of donating their organs after death for medical research. It's a situation that everyone has to decide for themselves. Science, constantly keeping your mind ticking over. This is 12-year-old Kristen Nugent. She suffers from epidermolysis bullosa, an extremely rare and painful genetic disease. That means her skin is so delicate it blisters and tears at the smallest touch. The condition for Kristen is so bad that the skin on her hands blister constantly, eventually joining her fingers together like a mitten. Even scratching herself creates blisters. Every year, surgery is needed to separate and straighten her fingers, and skin from her legs has to be taken for skin grafts, leaving open wounds which take months to heal. As we have seen, science is working on developing ways to help people with skin disorders. Soon there will be new artificial skin on the market which could help Christian. The bioengineered skin was invented by Dr. Michael Eisenberg, who has devoted his life to developing the product after his son was born with the same disease. The cultured skin is made from the cells taken from baby circumcised foreskins. The cell culture is mixed with the synthetic material and then placed onto open wounds, speeding up the healing process. The proteins in the cultured cell encourage the body's own skin to heal quicker. It also produces stronger, more durable skin. While the cultured skin is not a cure for EB, because the disease is genetic, it should mean that the wounds will heal twice as fast, making life a little more pleasant for Kristen and others with skin problems.
What's in a name? According to a professor of genetics at Oxford University, our names hold the key to our genetic makeup. Professor Brian Sykes has established a link between genes and surnames after examining the Y chromosomes of a group of British males with the same surname as himself. The DNA of 61 Sykes men was collected by brushing the inside of their cheeks. The brush tips were returned and the cells clinging to the bristles were examined. Professor Sykes found the genetic fingerprint of just over half the Y chromosomes of every Sykes male was identical. Chromosomes are the structure in each and every one of us that carries our genes. Genes contain all the information that is needed to make us who we are. They are passed on from our parents and ancestors. The X and Y chromosomes are the information needed to make us a boy or a girl. We get this information from our mother and father. A girl has 2 X chromosomes and a boy an X and a Y chromosome. Professor Sykes used the information created in the Y chromosomes to do his research. The reason he followed the males with the same name is because it could be likely that any Sykes females might have changed their name through marriage, and the Y chromosome is only carried in males. There's such a lot of variation in the Y chromosome in different people. You can recognise thousands of different versions if you like. And the versions which you see in the Sykes we haven't found anywhere else in the UK, he said. The Sykes family comes from the Yorkshire area in northern England. Genealogists had previously believed there were lots of Sykes founding fathers. This is because the name means a boundary stream, a very common sight in Yorkshire. To their astonishment, the findings show all living British Sykes can trace their male ancestry back to a single founding male, an original Mr. Sykes. That means that we human beings are more closely related than we think, as Professor Sykes discovered. Research with other surnames reveals the same results. Professor Sykes is now mapping distributions of surnames throughout the UK. His work will help genealogists trace family heritage. This often becomes frustrating, especially when written records become unreliable or disappear around the year 1700. The work can also prove whether variations on names like Smith or Smythe changed from a spelling error or a different founding father. Britain's Viking heritage is celebrated each year in York. With further research, Professor Sykes believes he will be able to distinguish a Viking Y chromosome from a Celtic one, giving historians a much clearer picture on how the country was originally invaded and populated, and what happened to the original Britons. Another spin-off is the newly established website, oxfordancestors.com, where genealogists tracing family trees branching to England can access a surname and have their own cheek cell DNA test done by post. So the next time you meet someone with the same last name, have a chat. They could be a relative from long ago. Still on the science of genealogy, it is estimated that 40% of the population of the United States can trace their roots through Ellis Island. Millions of immigrants arrive from Europe and elsewhere with dreams of a better life. Finding information on these ancestors has been difficult in the past. Now, a new interactive computer has opened for families to find their roots. The database is also available